Thanks to Michigan Technological University for supporting this video.
Do the frogs still have two heads? The first time I visited Torch Lake almost 5 years ago, that was the question I got from my family. And it sounds a little goofy until you realize that they lived in this area in the 80s, a time when the frogs probably weren't growing two heads, but the fish were growing tumors. And nobody really knew why. I mean, the basic answer was obvious. For more than 100 years, Torch Lake here in Michigan's Upper Peninsula was a key part of the local copper mining boom. And during that time, about 200 million tons of mine rock were dumped into this lake. And it wasn't just any old harmless rock. Even after several decades and millions of dollars, parts of this area are still so polluted that there are warning signs on the beach. This is the story of what happened here, how this lake got to be the way it is, and how this area is still cleaning up after its mining heritage some 50 years later. But first, welcome to Torch Lake. It's story time.
From the 1840s through the 1960s, people from around the world mined copper in the Keweenaw Peninsula, this specific part of Michigan's Upper Peninsula. This is an important chapter of history I've talked about elsewhere, but to give some highlights, this copper influenced wars, it allowed electricity to spread around the country, and it brought countless immigrants to the United States. During the mining boom, millions of tons of copper were extracted from the earth, and a lot of it was processed here, along the shores of Torch Lake. Between 1860 and 1970, so a span of 110 years, 8 different mills operated along the shores of the lake, crushing mine rock to separate the waste from the precious metal. The crushed waste rock looks like a dark, coarse sand, and it's called stamp sand, or broadly, tailings. And to get rid of it, the mining companies back then usually just dumped it into a nearby body of water.
So in like a modern mining system, that stamp sand has quite a bit of value to the company. There's a lot more environmental as well as like operational advantage to kind of transport those sands back to the mining system and cement them and use them as a backfill. 150 years ago, it was a big nuisance, right? It was in the way of the processing.
Now, at this general point in history, there were some rules about how much stuff you could just dump into a body of water. It wasn't totally the Wild West. But at Torch Lake, sometimes those rules didn't apply. Like, pollution restrictions at Torch Lake were waived from 1940 to 1965 because copper was so important to World War II and other war efforts. So, by the end of the mining boom around 1970, about half the volume of this lake had been filled in by crushed pieces of mine rock. But again, why is this a big deal? All sand is just crushed up bits of rocks and minerals and stuff. So what's the issue? What is stamp sand?
Essentially, it's a basalt rock. And so maybe like 99% silica and oxygen, but that 1% seems to be kind of problematic. Copper was the predominant metal that was extracted from that rock itself. And so we see trace amounts of copper within that stamp sand itself, but then a whole bunch of other kind of metals too, things like titanium and zinc, lead, arsenic. So things that don't necessarily get along well with ecosystems when they become mobilized. Because those stamp sands have been reduced in size, their surface area, like per unit weight, is tremendously larger than it would have been just like as an in-host rock in the earth. And so now that large surface area is in contact with many different physical chemical processes in the aquatic environment. And so that begins to leach things like copper, arsenic, lead into those water bodies.
So really, we've got two problems here. One is the physical problem. The bottom of the lake got buried. That's gonna cause issues. But also, and maybe more significantly, there's the chemical problem. Some of those metals Dr. Manser mentioned can make water non-drinkable for humans. And if dust from stamp sands is breathed in over time, it can lead to a lung disease called silicosis. But Also, even low levels of copper can be toxic to fish, amphibians, some wetland plants, and various little creatures important to the food web. And when they die, the fish populations go down too. In fact, as a theme, while copper can be dangerous to humans, it's even more dangerous to wildlife. So these sands aren't just ye old rock. And finally, remember how I said there were 110 years of industrial activity here? Well, turns out the stamp sands aren't the only thing polluting this site. And depending on your perspective, they might not even be the worst one. And that brings us back to the start of our story. In the 1970s, a few years after the mining boom ended, locals started reporting that the fish were growing tumors. Like I said earlier, the first suspect here was obviously the mining activity. But was it the stamp sands causing the fish tumors, or something else? What exactly had all that industry done to the land and the water? It was clear that Torch Lake was highly polluted, and it was time to start paying attention. The fish tumors concerned locals, research studies, and a growing sense of environmental awareness around the country all came together. And eventually, Torch Lake and surrounding areas were put on the lists for 2 programs tackling heavily polluted sites in the United States. One is best known as the Superfund list. This was a program started in the 80s by the US Environmental Protection Agency, or the EPA. It came with a federal trust fund, or Superfund, to pay for the cleanup of hazardous waste sites. The other program was the Area of Concern program, also set up in the 80s. This is part of a commitment between the US and Canada to restore and protect the waters of the Great Lakes. And while Torch Lake is not a Great Lake itself, it does connect to Lake Superior. So this place was labeled a Superfund site and an area of concern. Researchers were paying attention, the public was engaged, there was funding. It was time to figure out what was causing those fish tumors and clean up this lake. But then, after studying this area, the EPA concluded that the biggest problem here wasn't actually the fish tumors. It was the huge piles of stamp sands sitting on the lakeshore. After all, the wind could blow those stamp sands to new areas and turn them into an airborne contaminant. So the EPA spent most of their Superfund money covering those piles of stamp sand with topsoil, or capping them. And they also put plants on the capped sands so that their roots would lock everything in place. And this was an improvement. But you might also see the trouble here. Yes, those stamp sands on the shore absolutely needed to be dealt with. But that wasn't the only problem here. There was still a ton of stamp sand in the lake itself. Again, half the volume of Torch Lake was filled up with this stuff. And it's not going away on its own anytime soon. And here, I want to properly introduce you to Dr. Noel, a researcher at the nearby Michigan Technological University who's been studying this site for years and has been incredibly helpful in helping me make this video.
Well, when I first came here, actually, my department chair told me to avoid Torch Lake as a research site because it was politically too hot. But as any brash young professor, I ignored him and started getting classes involved as an opportunity to learn more about the lake. You know, the EPA's assumption when they remediated the area was that the lake sediments would recover on their own, which is a common thing that happens. Every year, erosion occurs in the catchments, brings sediments in, they cover up the contaminated material. But thanks to this big damp sand cap, which blocks the big river coming in, all of the sediment load brought in by that river is dropped on the other side of this pile and never reaches the lake. So what we found is that the rate of sediment accumulation in the lake is very low, on the order of millimeters per year, such that it would take a few hundred years for the lake to recover.
So the EPA might have addressed one problem, but that wasn't the end of the list. Now, to be clear, Torch Lake is in better shape than it was in the 80s. The piles of stamp sands on the shore more or less got covered up, and some sand on the bottom of the lake has been removed. Today, the lake is safe for things like swimming and boating. But more than 40 years later, Torch Lake is still considered an area of concern, and parts of the site are still on the Superfund list. Some of the issue is that all those little creatures on the bottom of the lake, officially called the benthos, they're still struggling thanks to the physical and chemical effects of the stamp sands. But also, as I hinted at earlier, the sands aren't the only problem. That century of industry left behind things including metal-rich sludges, coal ash and slag, and marine debris, including hundreds of barrels still on the bottom of the lake, some of which might still contain industrial waste. Plus, there are high levels of metal in the soil and nearby sediments, including metals like lead and arsenic. And then there are the chemicals in the water itself. Now, the good news is the fish aren't actually developing tumors anymore. When I talk about the chemicals in the water, that's not actually what I'm referring to. That is the rare problem that solved itself. Years ago, I made a video about this funny looking vacuum thing in Torch Lake that pulled stamp sands out of the water for further processing. Those sands were treated with chemicals to squeeze a little more copper out of them, and then those chemically treated stamp sands were chucked back into the water. Those chemicals were probably behind the fish tumors. And I say probably because scientists never actually got to prove that. Those specific chemicals break down really quickly in water. So by the time these cleanup programs showed up in the 80s, the evidence had basically disappeared. In any case, fish tumors have not been seen for many years. But you still shouldn't eat too many of the fish here, because the water is also contaminated with two types of chemicals you don't want building up in your body: mercury and PCBs. Mercury feels like the classic fish contaminant. It's especially harmful to children, and in high quantities can lead to neurological problems, among other things. Meanwhile, PCBs are a group of artificial man-made chemicals made of carbon, hydrogen, and chlorine. There are a bunch of them. Some are oily, some are waxy, but they all have no taste and no smell. They were manufactured from 1929 to 1979, and were really useful in industry because they're not flammable, they're chemically stable, they have a high boiling point, and they don't really conduct electricity. So you could use them for all kinds of things. Unfortunately, they can also stick around in the air, water, and soil for decades. And having high levels of PCBs is associated with everything from cancer to negative effects on the immune, reproductive, and neurological systems. Broadly speaking, PCBs are kind of similar to another group of chemicals that you might have heard about in the news more recently, including PFAS, also known as forever chemicals. But here's what surprised me about PCBs at Torch Lake.
When EPA made that decision that the blowing dust was the big problem, they really stopped looking for other problems. And so they looked at these vast extents of exposed stamp sands, but didn't look at the actual sites of the industrial activity. And just as at any major industrial site from 100 years ago, there are lots of waste disposed on site. Among those here were PCBs, which came into use in the 1930s and probably arrived here very shortly thereafter to be used in all the transformers on all of the mine buildings. So probably every building had transformers with PCBs in them. Those oils inside the transformers need to be changed periodically, and who knows exactly what they did with the spent oil. Maybe it was dumped on the conveyors along with the stamp sands and dumped into the lake, and that may be why it's found right in the bay behind us. Maybe they poured it on the ground, maybe they used it as fuel oil. We have evidence for all of those things. So from about 2015 to 2021 or so, there was a project by the DEQ called the Abandoned Mine Waste Project. And in that, the DEQ went around to all these industrial sites, did extensive soil testing, looking for PCBs in the soil. If they found it in the soil, looking for it in the groundwater. So yes, they found a few areas with contaminated soil. That was dug up and brought to a hazardous waste landfill. There was some dredging right along the shoreline here, and part of the reason for that was PCBs as well.
So, mercury, PCBs, stamp sand covering the benthos, soil contamination, and more. The fish might not be getting cancer, and it might be safe to go swimming, but Torch Lake is still polluted. Officially, according to the Area of Concern program, there are two main things to fix. They're called beneficial use impairments. The first one is the unhealthy benthos, and the second is the restriction on eating the fish. Now, I know that big projects take time, but this cleanup has been going on for 40 years. So why is it taking so long? Well, part of the answer has been funding. Funding has been inconsistent, and even in cases where there was money available, there sometimes wasn't a plan at Torch Lake to be financially supported. Also, the logistics have been complicated. There are a lot of parties involved here, from local researchers to the federal EPA to the International Joint Commission between the US and Canada. There's no one group in charge, and over the years, different organizations have focused on different things. Everyone's goals do overlap, but all of these different viewpoints have led to different ideas swirling around about what exactly the problems are. To make a long story short, this has sometimes made it hard for the public to understand what's going on. And when there's less public engagement, it's a lot easier for big organizations to deprioritize places like this, especially when those places are in small, out-of-the-way communities.
If the community had not kept coming back to Eagle and EPA and saying, no, there's still problems with the lake, we don't find it acceptable, the agencies would have walked away a long time ago. So it's that insistence by the local people for reassurance that things are healthy by them, that their kids are not in danger, that has resulted in the progress we see. Oh, there's definitely a lot of hope. I mean, the lake has improved tremendously since the stopping of the mining in about 1970. So at that time, you wouldn't want to swim. It was turbid throughout the whole lake, cloudy. Now you can swim in it. You can do all sorts of contact or non-contact recreation on the lake. The wildlife around the lake is fabulous. So the area right behind me, this entire bay is going to be dredged. Depths of anywhere from 6 inches to 9 feet of sediment are going to be pulled out of the lake, drained over on the shoreline, and then brought to a hazardous waste site. And that should remove a lot of the heavy metal contaminated sediments and PCB contaminated sediments in this bay. That's both the combination of EPA working together with Honeywell, because Honeywell purchased the land from Calumet and Hecla, the mining company.
Something Dr. Urban mentioned that I thought was really interesting was that the state of Michigan and the federal EPA are under pressure to remove Torch Lake from the Superfund and the Area of Concern programs. And once these upcoming projects are done, it is possible that they will try to start removing Torch Lake from those lists. But that doesn't mean this place would be fully healthy.
The EPA and Eagle have no qualms with saying this lake will never go back to the way it was originally. You know, the lake has been filled in 50% of its volume with stamp sands. Those stamp sands will always be in the lake. It'll take several hundred years to cover them up enough so that the copper from those stamp sands doesn't leach into the lake. And even that's misleading because on the steep slopes, sediment doesn't accumulate. So some stamp sands will always be exposed to the water. You don't have to worry about drinking the lake. What's in the lake is not going to hurt you. So right now, really the only threats are being exposed to the heavy metals from a couple of these contaminated sites, the ones that are going to be cleaned up in the next 2 to 3 years, and eating the fish. So yeah, I'm very hopeful. I'm really happy to see these most contaminated sites cleaned up. And I have to agree that there really is no feasible solution for cleaning up the whole lake. The state will cap some small sections of the lake, and that will improve the food for the entire food web as well. Never expect quick fixes. Sure. But that it's not hopeless, but it really requires involvement on the part of the community.
When our ancestors damaged the environment to get resources like metal or lumber, how far should we go to clean up after them and restore those places? Should we call it a day after 40 years and go focus on other problems? Or should we spend all the time and money it takes until we get things right? There are all kinds of sites that humans have left worse than we found them. And as individuals, we can't help them all. But I do believe this. No matter where we are in the world, we can all do something, no matter how small, to make our corners of the world just a little better than we found them. Thanks to Michigan Tech for supporting this video. If you want to learn about modern, environmentally conscious mining techniques and other exciting geoscience careers, you can reach out and connect with Michigan Technological University's Geological and Mining Engineering and Sciences Department. And if you want to learn about rewarding careers in environmental remediation, you can reach out and connect with their Civil, Environmental, and Geospatial Engineering Department. Links to their websites are in the description. And as always, thanks for being here. I hope you learned something that makes you think about the world just a little differently, and I'll see you soon.